So now, I thought I would just cover some basic topics. We have a couple resistors right here. So these are 220 ohm resistors. I can measure their resistance with a multimeter. Right there, the omega symbol. Pretty straightforward. I don't have to move the red probe for anything than high current. You can see the omega symbol right there. So, in any case, they are 220 ohm resistors. Most likely we will not see 220 on here. They have a 1% tolerance. They could be 1% higher or lower than their rated value. And these are cheap resistors, so it's probably even worse than that. But that's what it says on the tolerance band on the resistor. It's brown for 1%. Be aware of that. So I think this one is slightly higher. But in any case, it's close enough to 220 for most purposes right there. So if you want a 440 ohm resistor, then what we can do is take these two 220s and put them in series right there. Now you're going to see close to 440 ohms of resistance. A bit lower because they're both a bit lower than 220. But there you can see we're about almost 430 right there. And if our goal was 440, this is probably okay right there. So as you put resistors in series, their resistances add up. Simple math right there. Now they're going to pass current, the two of them. If you had a single 440 ohm resistor, or using these two resistors, that 440 ohm resistor will get twice as hot as each one of these. They'll split up the heat that is generated. So sometimes you might use lower value resistors in series like that to help dissipate heat, if that's going to be a problem. Now we're going to put them in parallel right here, which is another reason why you might use resistors to help dissipate heat, putting them in parallel. But funny thing about parallel resistors is the resistance is always lower than the value of either resistor. So we have here about half of 220, about 110 right there. Very easy when they're equal value resistors. When they're not equal value resistors, you got to use one or other formula depending on how many you got. And you got one formula if there's two, and then there's another formula for two or more that you can use. We're not going to worry about that too much. This video, I just want to quickly show parallel resistors have less resistance. So now, the reason why I say this helps with heat dissipation is that if you got a voltage across here, current is flowing, half the current's going to go through one resistor and half the current's going to go through the other resistor. So they divide the the current in half for each of them. Each one of them is going to take half the current, I should say. And therefore, instead of a 110 ohm resistor, which has all the current flowing through it, we have these two separate 220 ohm resistors with half the current flowing through them for a given voltage. And therefore, each one of them will get half as hot as a lone 110 ohm resistor would if it was substituted for them. As soon as you're done with the meter, it's safe to have it on resistance and voltage. This has an off setting though. We got to set it to off. But never leave it where it's measuring current when you have it unattended, because if you accidentally measure a voltage, you could damage it. Just a tip I try to always mention when talk about multimeters. And so I figured I would mention again. Now, that's it. Thanks for watching. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you on the next video.